in chapter 14 also. They are very short chapters. So I'll give you what is the most important. So ICMP, it's a protocol to test connectivity. For example, can I dial Keegan number? Is he going to pick up, or is he going to go on voicemail? Or if I want to trace someone via a cell phone, from which cell tower to which cell tower until it reaches Keegan or right. So that's all, is to test connectivity. So here we have two tools that we'll use. It's the ping and the trace route. If you watch American movies, we'll say trace route, but British trace route. So if you know these two, it's fine. Anything else is extra info. So what's the most important? I prefer giving what is the most important. So you see here, explain how ICMP is used to test network connectivity. Then inside, we have two tools that we'll use to test, ping and trace route. That's all. If you know that, nothing else. NetAcad will give as much as a lot of information, because in the old days, it was books only. Then we had to go to YouTube, to Google, buy other books. So we decided to combine everything in one place so that you have all information you need. You see, no one needed to go to Google, to YouTube, to what. Okay, so let's check a bit what we can learn that is more relevant. Okay, this one is not quite. So for example, if PC1 want to communicate with PC2, and you're going to send, and like hello, and you're going to send a hello message. If he receives, he's going to send hello back. Then we can start sending. So sometimes we use it for troubleshootings. For example, I cannot reach a website. Then you're going to use these two tools to check what is wrong. So when you ping and you're sending a hello, and if he replies back, say, he's live, we can communicate. So if I dial Keegan's number and it rings, it means we can communicate. If he picks up, it's fine. If he doesn't, at least we know that the number is correct. If it reaches the voicemail or a message, your destination is unavailable, then it's something else. So that's all for this chapter. How to. So if you can't reach someone, you have some error codes. For example, if I dial and I go to a voicemail, welcome to the voicemail message of, it can be code 0 or maybe code 1, host unreachable. So when you ping your stuff, you will get some feedback, some code. And from the code, or if you want to visit a website, you can get an error code and you can check them here. So here will be for IPv4 and here will be IPv6. So you can have a look and you continue. Okay. So if someone want to ping, okay, we'll do some examples soon. So we have ping and trace routes. So this guy, for example, was trying to dial someone's number or ping a destination IP address, and we see 0% lost. We send 4 packets, we receive 4 packets, it means we can communicate. So we have for IPv6, we're not going to touch that for now. So IPv6 from time to time, when we do labs, we're going to use them. But for now, we can skip. Now, the 2 tools we use to test connectivity is ping and trace route. So if you use your switch and you want to ping a number, if you see exclamation mark, it means it's successful. So you can have a look here and you can. Okay, so we'll get time to, and we'll do from time to time some labs. If you want to ping yourself to check if your network card is working properly, you ping this number 127.0.0.1 if for IPv4. If it's for IPv6 is :::1. So you can also check that. Okay, so we'll try to do some demo. I'm going to check if I can. So if I want to ping my own network card, so I do ping 127.0.0.1. So 0% lost. So I send 4 packets, I receive 4. With time to leave, it means, for example, if I send you to buy bread, and after 5 minutes, you cannot get any bread at any shop, please come back, return. Or you can get discarded. It means I'll get 100% loss. So here I have 0% loss. It means my network interface card is working properly and I can ping my. So if I use for IPv6, you see also I have IPv6 enabled on my network interface card, 0% loss. It means I'm good to communicate with anyone. There is another tool called traceroute. For example, if I ping cisco.com, to check if I can open that website. You see, so I can communicate, 0% loss. Now, if I want to see, so when I send my packet, where it goes until it reaches cisco.com web server in US, then you say trace, trace with route, RT, trace RT. and we type cisco.com. Let's see if I type help. Do not resolve address of host name. -d. Okay. Okay, so I'm going to do that -d. So what's wrong? Do not resolve, yes. Please run to 6 minutes. Maximum what? Let's say 20. Okay, this one is too complicated, so I'm going to remove. We tap traceroute cisco.com, we press enter. So the packet will first go to my default gateway because he want to go out. So this is my default gateway name and the IP. Then it will go to my ISP. My ISP will go to wherever until it reaches cisco.com in US. Sometimes it takes time. So that's all. These two tools, we use them for troubleshooting. If, for example, someone say, I cannot reach a PC, I cannot ping, I cannot communicate, we use these two tools to check. Like you bring some detective to check people. They're going to trace to do their own stuff until we find. So we'll do some labs for IPv4, IPv6. We're going to do some trace roads, some ping. So this chapter is very short one. Is to test connectivity. We use ping and trace roads. So you can have a look at this and we do the other chapter. That is also a short one. Okay, so we can get time to check that. Any questions? So now we're going to do the other chapter. So all these remaining chapters are short ones. The long chapters were subnetting, IPv6, and other. Anything we do now are very short, are simple. You just need to read, take your note, and there is no labs for that. So we'll keep doing some labs for IPv4, IPv6, subnetting. Yeah, like also something like we did on Saturday, the physical mode. So chapter 13 is simple, network connectivity using ping and trace route. The other one, the transport layer, is also some theory. Only three things to know. The definition, what a transport layer does, and the two protocols, TCP and UDP, inside. And yeah, that's all. I want to make it very simple for you so that chapter 14 I did open, but now what is it? Oh, yeah. Chapter 14 is here. So remember the OSI model, we started with the physical layer, then we went to the data link layer, then the network layer with IPv4, IPv6. Now we jump to the transport layer. So definition of transport layer, what we do, the two big protocols we have there, TCP and UDP, that's all. Anything else is extra info data you can use. So let's check what we can do. Yeah, so you can have a look on this, what you're going to learn, then you continue. Okay, so if you know the definition, so this is what the transport layer will do. So the transport layer is responsible for logical communication. So it makes sure, so like you build roads from Cape Town to Pretoria for people to use it to reach the destination. So responsible for logical communication between application running, the link between the application layer and. So some responsibilities, tracking, so you can have a look here. It's something simple. You don't need to memorize, but just to have an idea. Okay, that's only theory. So inside the transport layer, we have two families. We have TCP, that is more secured, and UDP that is not secured. So it's more for light applications, like DNS, TFTP. So here we don't need to, we don't need identification. You don't need to show your ID before you go in. You don't need to use your fingerprint. It's simple. It's open door. The TCP, more security. If you want to transfer a file to somewhere, you need username, password, and other stuff. So have a look on this one also. So we can ask you, for example, which protocols use list some protocols that use TCP. So we have ATP, HTTP, SMTP. SMTP is a protocol managing emails. Protocol is what? It's a set of rules to organize communication. How are we going to communicate? Like for us to do our classes, we know that Monday, we agree. Mondays, online teams from that time to that time. So it's an agreement. So it's the same thing. How are we going to exchange emails? So we have a set of rules and agreement. That's when we call it a protocol. And the package doing that is called SMTP, Simple Mail Transfer Protocol, something like that. To manage the web, we also have the same thing. How are we going to exchange or download web pages, upload and what? HTTP, we're going to manage that. If you want to transfer protocol, to transfer files, to upload files on Gmail or Google Drive or what, to download, to upload, is FTP that does that. Must first check, do you have internet connectivity? Do you have enough space on your hard drive? Are you allowed to do such thing? You see, then you can download all. So now here we're going to try to explain more in details what is TCP, Transmission Control Protocols. We're going to explain more what is inside. We're going to also explain UDP. So UDP is connectionless. It means if I want to communicate with you, I don't need to tell you first to wait for me, to listen to me, and to reply to me. All this stuff, all this safety stuff are for TCP. It's going to control my package I send. Is it arrived? Am I going to receive a receipt to confirm that? You see, all these security stuff are done by TCP. UDP, I just send my letter at post office, done. Destination arrive or not, no notifications. So there is no acknowledgement that the data is received destination. So check this, it's quite important. Okay, what else can we check? So here we have some how to compare TCP and UDP. So UDP mostly voice over IP are using UDP. DNS like Cisco.com and the IP address domain name resolution. And for TCP emails or HTTP. So you can check these two. It's very important to know them. Okay, what else can we check again? So Anything else we're going to do now is only some theory and short chapters. Mostly we don't have any labs for that. So TCP, it's more secured. We need to establish a session first, ensure reliable delivery, and you see. So you can also have a look on this. Okay, this one you can check a bit later. So some applications using TCP, we have HTTP, FTP, SMP, SSH. After that, for UDP, if you have any questions, you can. Okay. Okay, after UDP, we'll check also some protocols using UDP. We have TCP, DHCP, DNS, and all this stuff. So you can have a look and then continue. So normally that's all for transport layer with definition. What is TCP, UDP, how to compare them, and some protocols that using TCP and UDP. If you know that, that's the main thing you need to. So before we get to port numbers, I want to check something for you. Okay, let me check first. I'm going to make it very simple for you. UDP. Okay, so here we have a definition, transport layer, the definition. We have a TCP, UDP. We have a definition between these two and how to compare them. Now, something that is very important, the TCP and UDP transport layer protocol use port numbers to manage multiple simultaneous conversations. So it's what we're going to check now, port numbers. So first, read here, then I'm going to explain to you and show you some port number stuff. So each application, so you see, for example, we have an event, and you have many people coming. So how security guy we going to handle the traffic? we're going to organize in parking lots. Say, okay, people coming from, let's say, Johannesburg, park here and use that lane. People coming from Durban, use that lane. People coming from, you see. So to manage that flow, we organize them in lanes, yeah, or in rooms. It's what is called port numbers. So if I have a web page coming, we have email, I have FTP, I need to organize them. So TCP and UDP transport layer protocol, we're going to use port numbers to manage multiple simultaneous conversation. Each application process running on a server is configured to use a port number. If you use the web, we use a port number for that. Use emails, we use a port number. So that it's well organized. There is no traffic, there is no collision, there is no. So these port numbers you can automatically assign, or yourself you can create them. So let's check a bit of port numbers quickly. For TCP, UCP, we're going to use port number, okay. So if you send a packet, a web page, in your package, there is a port number, say, okay, I'm using web page packet port number, let's say 10. So when the destination we open the packet, you see, this one is for communication number 10. It's for the web. Let me also send it to my web. So everything is well organized. If not, it will be a mess, collisions, loss of packet or loss of courier and all this stuff. So something that's very important that we should know is these ones. It's compulsory for you guys or for us to know them by heart. At a first view, it's difficult, but we're going to use it a lot, especially CCNA2 and CCNA3. So if you're using emails, the port number is 25. It will go out. The same thing like at the airport. If you want to take your plane, we say go to gate 10. If you want to go to Dubai, go to gate 10. So emails, it's gate 25. If you want to go to China, go to gate 80. So anything related to HTTP to the web, it's port 80. So everything is well organized. So have a look on this. Okay, so we'll use them a lot for CCNA2 and CCNA3. So for now, we are preparing you. That's why CCNA1 is Introduction to Networks. You're in grade 1. We are preparing you for good stuff, CCNA2, CCNA3. And we are much easier than CCNA1. CCNA1, everything is new. We don't know. Now we know how to do labs, how to do the terms. So CCNA2 and CCNA3 are more easier. So I think, yeah. Let's say that's all we can do for today. Anything else? So TCP connection, because it's more secure. For example, A want to communicate with B. So there is something in the background before we start. For example, if I dial your number, my call will go to the cell tower. The cell tower will look for your number until it rings on your number. Listen, so we have something in the background. So if I want to communicate with you, I send a packet. We call it the send packet. B will say, okay, send receive. And B also will reply to A. Seen act, and we call it handshake and three-way handshake. So you will face this one a lot in TCP. So you can have a look on this one. This one is very simple, and then we continue. So step 1 is here, send a message. Step 2, B will reply. And step 3, A will also. So have a look. So for exams, and we can ask such things. And there is also something called session termination, number 4. So you can have a look later in your. So this is what is very important in TCP, the three-way handshake. It's exactly what we just checked. So UDP, I send my letter at post office. It arrives to destination or not, no one knows. There is no notification. TCP, everything, it's like you have a track number. You can follow it, you can track it via the website until it reaches destination. And you will receive a notification that, yes, your parcel has been delivered. The same thing for TCP. Okay, I think that's all for, so you have a video. We explain all these things. Anything else we can skip? It's extra info. It's extra info. But the main thing we should know is what we did. So have a look on the summary again, and we continue. Okay, guys, I think you can get more time to continue in NetAcad. So yeah, these chapters are short ones, and then so on Wednesday we'll finish application layer, very simple. Network security, build network, we can combine them. We are very short ones. And Saturday, we want to go at CPUT. We'll do online. I'll tell you which lab you can prepare for Saturday. So this coming Saturday, Wednesday we finish the last 3, and Saturday we stay home. We do on Teams online.
What time on Saturday, sir? Because Saturday is a church day for some of us in the morning.
So until what time?
We normally start early until 1 o'clock.
Sorry, I cannot hear you.
Until 12 or 1 o'clock, depending where you are, where we are going to go.
From what time to what time?
Let's say 9 to 1.
Okay. So then, can we skip that Saturday then?
For me, yes. I don't know about the other people.
Yeah, we are in democracy. Who want us to cancel this Saturday?
That's fine.
Okay, for Light it's fine. For Keegan?
Yes, it's fine with me, sir.
Okay, and Mrs. Kutiyale?
It's fine, sir.
Are you sure?
Yes, I'm sure.
Okay. Zianda? And Emmanuel?
Oh, good, sir. That's fine.
Okay. So what we'll do Wednesday, we'll try to finish the last 3. We'll take maybe 2 hours. Eat well, get ready, we finish and we are done. Saturday, you can relax, you can go to church, or if you want to do your labs, you can do them. If you want to do your revisions. Then the following week, we'll do revisions. If one didn't put exam, so we do revision until one set up the exam time, exam period. So please register, pay your fees, so that one can help us to go ahead. So the following week we do revisions, labs, a lot of labs. If the second week there is no exam, we continue. But I'm sure from the 15th there is an exam.
Thank you very much,
Any questions?
sir, for understanding.
Sorry?
Thank you very much for understanding.
No, you're welcome. It's Easter week now. Yeah, so we finish, we take a short break, and we continue. Okay, guys, thank you very much for today, and see you again on Wednesday.
Okay, sir. See you. Bye-bye.
Okay, bye-bye.